Good morning, folks, and thank you for attending this morning, afternoon, or evening, whatever time it may be, wherever you are in the world. Today, we are going to be hearing from some developers of Snort rules, specifically on the subject of writing Snort rules. So the Snort 3 and Me series will continue. Just a note, as mentioned earlier, that if you have any questions, please use the Q&A tool and we will try to answer them during the presentation. If some of them pop up and we think they're particularly interesting beyond just the typed answer, we may try to address those at the end as well. This is being recorded. As I've noted in the chat, if you have any questions that you want to ask privately, please send them directly to me. That's R. Albach, RALBACH at Cisco.com, and we will get them addressed. Thus, no further ado, let's hand it over to Brandon.
Hello, everyone. My name is Brandon. I am a tech lead at Cisco Talos, and I'm joined by my colleagues Jeff, John, and Nick. And we write a fair bit of rules here within Talos. We also deal with the engine, and that's what we're going to talk about today. Specifically, what are Snort 3 rules? How do they differ from Snort 2 rules? And then we're going to go into some vulnerabilities. I have 3 real-world vulnerabilities we're going to cover today: a command injection vulnerability, a directory traversal, and a buffer overflow. And then John is going to take a look at the Snort to Lua tool, which is a tool for converting automatically your Snort 2 rules to Snort 3. And then finally, Jeff will close us out with a look at the detection trace, which is a pretty neat feature of Snort 3 for debugging rules that you're writing. So first, before we get into Snort 3, just an overview. Snort 3 is the engine for Cisco Secure Firewall. It inspects network traffic. It dissects the traffic on a protocol and file level. It isolates vulnerability conditions. It identifies malware command and control traffic. It inspects files and alerts and or blocks on that traffic that meets those conditions. So let's get into some rule basics. What makes up a Snort 3 rule? It's very similar to a Snort 2 rule. So if you've seen a Snort 2 rule before, it begins with a header. The header includes the action that you want to take on the traffic that the rule is matching on, the protocol that the rule is matching on. This could be TCP, UDP, ICMP. The source address, and destination address are in CIDR format, so if you're familiar with that. But a lot of people use variables for noting their internal and external networks, and usually have external net, home net in the source and destination addresses. There's also source port, which could just have a wildcard, as you see here with any, or it could have a range of ports or a group of ports. So that's the Snort 2 style rule header. We thought this could use some simplification. So in Snort 3, we've introduced the service rule header. So a lot of times with Snort 2, you would have to configure your inspectors to look, say, on port 80 for HTTP, and your respective ports for POP3, IMAP, SMTP, anywhere where exploit traffic could flow. We thought this could use some simplification, so we just reduced this to alert HTTP and any other service that you want to scan. The Snort 3 engine has built in it something called the wizard. The wizard has spells, curses, and hexes that identify services that are flowing over your network, and you don't have to configure ports. It just figures out whether or not HTTP is flowing over a particular port, and then engages the rules that have that service on it. It's pretty neat. So whenever you wanted to scan files in Snort 2, you had to use this somewhat complicated rule header that had a collection of ports that files could flow over, like the ones I mentioned: HTTP, POP, IMAP SMTP. We thought this also could use some simplification. So in Snort 3, you have the alert file rule header. So file is kind of an alias, a service alias for all the services that files could flow over. Another cool feature of Snort 3 is if a file is identified as having compressed data within it, say it's a zip file or one of the new Office formats that use zip under the hood, then the service rules will be able to look inside those Office documents. So say if you're looking for a malicious VBA macro or any, like maybe a malicious directive within a Office document, like a recent Microsoft O-Day may have used, then an alert file rule would be able to scan within that Office document and identify and drop that flow. So let's get into, that's the rule header. It's a quick overview. Let's get into rule options, which are really the meat of the detection. So the simplest rule option is the content match, which just finds some static pattern in network data, and it could be on a protocol that you're matching or a file format that you're matching. And this is what a Snort 2 content match would do. It would have buffer selectors that would reduce or select buffers that the content match would operate on. Here we have a content match foo and a content match bar, and they're both matching HTTP URI. But you probably noticed that we have to repeat ourselves. For every content match, we have to tell Snort 2 where we want that match to occur. So we thought that could use some simplification in Snort 3. So here's what it looks like in Snort 3. We're using that service rule header above, alert HTTP, but we only have to select our buffer once. So in Snort 3, all buffer selectors, like HTTP URI or any of the other buffers that we'll talk about here in a minute, are what we call sticky. So that means if you declare a buffer selector, then you're going to remain in that buffer until you select a different buffer. And that just cuts down on the how verbose your rule is. It makes it easier to write, we think. Another thing you may have noticed, I can go back here really quick. The arguments to the content match in Snort 2 occur after it. So you have a content and then you say you want it to be distance 0 away from another content. So here we have patterns that are relative to other patterns. So in Snort 3, we've moved arguments into the content, the actual rule option itself. So, and we've standardized it. So in Snort 2, you had some that used this syntax where arguments were comma separated, and you had some that had the old syntax where arguments came after a rule option. We've simplified it and standardized it to where every argument for a rule option in Snort 3 is comma separated within an argument. So we think that simplifies the syntax drastically, and we hope that you like the new syntax. We do, certainly, within Talos. So let's go over some of the common buffers that you'll see when you're writing rules for blocking exploits. So here are the buffers that were available in Snort 2 and HTTP Inspect. And it's pretty much every part of the request that you would want to match. You have the method up above. Just as a quick refresher, in HTTP, whenever you send a form or you click submit on a page, this is the kind of traffic that you would see over the network. The parameters that you selected in the form would appear either in the query or the body. The query is up above, and the body's down below there in the example. So you've got the method you can match on, the URI, the headers, if you want to match on things like a user agent, say you're matching malware command and control traffic that has a specific user agent. You've got cookies available. So it's pretty complete, but one thing that we thought would help tremendously is to allow you to drill down even further in Snort 3. So in Snort 3, we've kind of made this more specific. So now we've broken the URI out into the path part of the URI and the query part of the URI. We have something new called just-in-time buffers. So if there's a piece of the header, for instance, that you want to isolate, say it's the host, you can use the HTTP header argument field host, and that will create a buffer that just contains the host, the value of the host header. So that's pretty neat. You can see that I've selected the HTTP header field host, HTTP header field content link. Those are separate buffers. You can make content matches on or perform any rule option options on. And then there's a new one that's fairly recent that is called HTTP param that I'm particularly proud of, because it allows you to match a parameter or isolate the value of a parameter regardless of where it is. So sometimes attackers will, if they see a signature that is, say it's detecting exploitation in a specific parameter in HTTP, they might say the parameter match occurs only in the body and the signature, they'll move it to the URI into the query and to evade the signature. So HTTP param kind of gets rid of that evasion entirely. And we'll see use of that in our rule writing examples. So now let's move on to actually writing rules. So we've talked about the basics, what all the different buffers that you can use. Let's take a look at some real world exploits and see how you would block those on Cisco Secure Firewall and open source Snort 3. So the first one is command injection. Command injection is a fairly simple exploit type, and it just involves a program that takes unsanitized input and sends it over to maybe a system call or a pipe open, any method or function that launches a system command shell and takes unsanitized input is vulnerable to command injection. So it's a really common exploit type, and attackers love it because it's fairly simple to write exploits for. So here we have a command injection attack, and I've shortened it because the remote code is actually wouldn't fit on the slide. But you can see here that in this parameter called spare community sent to this PHP application, there appears to be some malicious data. If you remember your ASCII table, 3B is a semicolon. So that's a shell meta character. And those characters are used to break out of the current command. On the back end of this application somewhere, there's a system call, and that 3B would break out of the flow of that system call and execute the attacker's command. So let's take a look at that code that's running on the back end. And one thing that I like to do is break out the code and follow the flow of exploit data as it flows through the application. So there you see in PHP, you can access the post variables with the post hash table. So it's looking up spare community and storing it in this array value for SNMP community. And then it's going to call a function called setCommunityName with that value. That function is going to pass that into a shell command like we talked about before. So it's going to execute this serve webexec and then SNMP setcom, which is an argument to that, and append whatever the attacker sent in spare community, and then finally execute that command with system. So fairly straightforward command injection vulnerability. So what do we want to detect here? So a lot of times when new rule writers are detecting things like command injection, SQL injection, they end up writing their rules based off of the actual exploit traffic. So they might match things like, semicolon echo, or they might match some piece of the remote shell that's being uploaded. This is the idea of matching payloads is good, because if you want to, narrow your detection down to what's malicious and not potentially block normal application traffic, then that's a good technique for reducing false positives. But it also creates tremendous opportunity for the attacker and false negatives, because the attacker could just choose a different payload to upload, right? So we have to think about what doesn't change in a vulnerability. So when you're writing rules against an application that's vulnerable, you need to think, what about this application does the attacker have to send? And usually with command injection vulnerabilities, the attacker has to send shell metacharacters. So there's some flow of the command that needs to be broken up by the attacker. In SQL injection, the attacker has to usually send some SQL metacharacter, and this, in the same sense, in a command injection vulnerability, the attacker has to send a shell metacharacter more often than not. So what are the shell metacharacters for review? We have command substitution, command sequencing. That's that 3B, that semicolon that we saw before. The attacker could pipe the command to another command. The attacker could background the current process or and the current command with another command. And there are subshells that you can that redirect output for standard in and standard out that they could use. So that's most of the shell metacharacters. How do we get these into a rule? So the usual way that we get these into a rule is with regular expressions. And I'll go over some of the techniques that you can use for matching these shell metacharacters. Usually it just involves placing the shell metacharacters into what's called a character class, which just matches any character. It's like ORing the characters together. You match, command substitution or command sequences or pipes or process backgrounding. So in Snort 2, what you would do is you would take a look at that post request and think, all right, well, this is only going to be sent to admin notification, right? So we want to match that URI. And where is the vulnerable parameter? Well, the vulnerable parameter, as we saw when we broke down the code on the back end, is spare community. So we're going to match spare community in the client body. And then here in this regular expression, you see what you would have to do in Snort 2 is you'd have to break up every one of those shell metacharacters that the attacker could use. So they could, all of the backtick, semicolon, pipe. And here I just have them in ASCII notation, or escaped ASCII, so that the regular expression could match all of them. But as I said before, in Snort 3, we want to simplify this process. So we have that new HTTP param rule option. How can we take advantage of it? Maybe the attacker, maybe somewhere on we saw that the backend application looked at the post hash table. Maybe somewhere else in the application, the parameters pulled from the URI or the get hash table. And if that was the case here, this Snort 2 rule would not function because it looks specifically at the post or the HTTP client body. So how would we account for that evasion and prevent the attacker from exploiting it in that scenario? So in Snort 3, we don't have to worry about where the parameter occurs because we can use HTTP param. So here I've isolated the admin notification match to the URI path because I know that's not going to occur in the query. That's the path that the attacker is targeting. The parameter I want to match is spare community, and I've also made it no case. So it will match any version of that. We had that in Snort 2, but now with HTTP param, it will match spare community in either the URI or the post body. And then finally, we have a much more simplified regular expression where we're just matching the metacharacters that the attacker could use. We don't have to worry about percent decoding because Snort 3 handles URL decoding in the post body as well. So we have a buffer that's completely isolated that we can scan. and we won't run afoul of false positives over false negatives with this signature. And also, I think it's much easier to read. So let's get into our second vulnerability. So directory traversal is a much simpler vulnerability, I think, than command injection. It just involves sending traversal sequences in a parameter. So here we have what looks like another post upload, and this time it's multi-part encoded. So it's a complete form that's being sent, and the file name for this form has the traversal sequence in it. So what the attacker is doing is, if you've ever heard of WMI exploitation, the attacker is placing a moth file into the moth directory, and that moth file will get automatically executed once it's uploaded. So detecting this just involves looking for traversal sequences, which are .. Here in Snort 2, we have to account for exactly, the HTTP client body, and we need to, move the buffer down each time. So we've matched the vulnerable URI. We've matched the fact that it's a multi-part post with the content disposition header, and we've matched the file name, and finally matched the traversal sequence inside the file name. Here's what it would look like in Snort 3, and it's just a more specific rule, and also, I think, much easier to read. So again, we've isolated the URI match to the path. We selected HTTP client body. We don't have to repeat ourselves because all the buffers are sticky, and we've matched that traversal sequence as before. So now I'll get into the final example. This is a buffer overflow example. I believe this is from a consumer router in Germany. I think it's called Fritzbox, and it has a buffer overflow in a XML SOAP upload. So here, a XML tag called command has a command and an argument. And you can see I've kind of truncated the buffer overflow section where we just sent a ton of A's to it. So on the back end, what does this look like? It looks like the router is actually allocating a stack buffer of 256 bytes, and they're going to scanf the SOAP uploads argument for that SE command into this stack buffer. So whenever you're exploiting a stack buffer overflow, your goal is to overwrite the return address. And a lot of times on consumer routers like this, there is no address space layout randomization, and there's no really any stack overflow protection that's on the router. It's kind of like bringing back the 90s of exploit, smashing the stack for fun and profit. But blocking this buffer overflow attack really just involves matching the traffic the attacker will have to send. So the attacker is going to have to send over 256 bytes in that argument that we saw before. So in the Snort 2 rule, we're going to have to match the vulnerable tag, which is command. But even before then, if you notice in the traffic, there's this DSL CPE CLI access, which sounds malicious in of itself. But the tag is required because it's a parent of that command, the vulnerable command tag. So we can go ahead and match that as well in our rule. So we'll match that DSL CPE CLI access. Where will we match it? We'll match it in the HTTP client body. We'll match the vulnerable command tag also in the body. And then we'll see with this isData@ rule option if there are 256 bytes in that tag. And then we have the negated content match, which just means, make sure that we can't match this condition, which is the close of that command tag within 256 bytes. And then finally, we have a PCRE that verifies everything we have above, which is the command tag and its argument have 256 bytes inside. So what would this look like in Snort 3? So we have the service rule header, alert HTTP. There's the message for Fritzbox stack buffer overflow. Remember, we only have to select the buffer once, so we select HTTP client body. We match our vulnerable XML parent, which is DSL CLI access, the command tag, 256 bytes of data there, no close within 256 bytes, and then finally verify that argument has 256 bytes in it. So that closes out rule writing, the basics, 3 real-world vulnerabilities, command injection, buffer overflow, and stack buffer overflow, or command injection, dirt traversal, and stack buffer overflow. And now what we're going to talk about is how you can translate automatically your Snort 2 rule set and translate it automatically over to Snort 3. So we built this tool called Snort to Lua, and John is going to talk about that.
Yeah, hey, you want? There you go. Share my slides real quick. Alrighty. Hey everyone. My name is John. I'm an analyst here with Talos. Write a lot of Snort rules, and as Brandon said, we're going to talk to you about Snort to Lua. So what is Snort to Lua? So to put it simply, Snort to Lua is a tool that you all can use to convert your existing Snort 2 rules to Snort 3. It's a standalone binary that's installed alongside Snort 3. So whenever you download Snort 3 from GitHub, build it, install it, you'll also have Snort to Lua installed right alongside it. So Snort to Lua is really powerful. What it does is it basically goes through all the rules that you have, all the Snort 2 rules that you have in a rules file, parses each one, and figures out what from those rules needs to be updated, and then how to update it, how to update them. And then once it does that, does its conversion, you'll have a basically a brand new Snort 3 rules file that will be fully compatible with Snort 3. To kind of put it into perspective, we actually use Snort to Lua internally to convert our nearly 60,000 rules to Snort 3. So obviously we trust it, and we know it works well and does the job it's supposed to. So it's very powerful, yet at the same time it's also really pretty simple to use. Put the command line syntax here. It's pretty easy. Just Snort to Lua, text C, followed by the name of the Snort 2 rules file that you have that you want converted, and then lastly followed by tech R, and then the name of the rules file that you want the converted rules to be placed in. So that's what it does. That's kind of an overview, but now I want to talk about some of the specific things, some of the more important changes that it makes to a rule. I've listed off a few here. Some of the obvious ones that you all may have noticed earlier is that we have here in Snort 2, we have semicolon separated content match modifiers like depth, offset, distance, within, and then Snort 3, these are comma separated. So the comma is placed after the content match with these, and then once you're done specifying all the modifiers, then you finally close up the option with the semicolon. So that's nice, and Snort to Lua handles that. The other big thing are the new sticky buffers that Brandon talked about. So like Brandon said, our HTTP buffers are now sticky to kind of make our rules simpler and a little bit easier to read. So on the left side, looking for HTTP URI after admin panel, that would in Snort 2, that's placed after each match you want to match there. Whereas in Snort 3, it's updated with the sticky buffer. Same thing with raw bytes. Raw bytes is now raw data, and that is also a sticky buffer. So same thing there. In addition to that, Snort to Lua will also replace and remove any options that have been deprecated in Snort 2. So the examples I have here are URI len and then fast pattern only. In Snort 2, we have URI len, which is used to check the length of a URI buffer. That's been removed in Snort 3. And so to replicate that functionality, whenever Snort to Lua sees URI len in a rule, it'll update it with to use the HTTP raw URI sticky buffer, followed by the new buffer len option. So it'll handle that for you as well. And then fast pattern only. Fast pattern only has been, you all might have noticed this as well, but fast pattern only is no more in Snort 3. The reason being is that previously we would have to explicitly set fast pattern only on rules to tell Snort only to evaluate an option once. Whereas in Snort 3 will do that intelligently. It'll know if it's able to evaluate a rule just once, and so we don't have to explicitly tell it, which is nice. So Snort will handle that as well. And then the last example we have here, I want to use this one to just kind of highlight that there are some minor syntax changes here and there that have been made to Snort 3. So on the left side, this option is used to specify a DCE RPC interface. Previously in Snort 2, you would just use the keyword followed by the UUID. However, now in Snort 3, before you put the UUID in the version, you have to actually put the string UUID in version. So there are a lot of small things here and there that have been tweaked with Snort 3. But the point being is that Snort 3 will handle, Snort to Lua will handle all of that conversion for you, and give you a well-formed and rule that's compatible with Snort 3. So here's just a quick example of using Snort to Lua. So I have my Snort 2 rules file. Looking for /admin panel in the HTTP URI with fast pattern only. So I have that rule there, and then simply run the command using the syntax I highlighted earlier. So Snort to Lua tech C 2 rules, tech R 3.rules, and that will, if all goes well, it'll output a 3.rules file containing the newly converted rule. And then if we cat the 3 rules file here, we will see it. So we see the new sticky buffer, HTTP URI before the content match, and then we also see fast pattern comma no case that replaces fast pattern only. And the other thing I wanted to highlight here is that if it can, sometimes Snort to Lua will add a comment above the rule to give a little bit of context of what might have happened with the rule. So if you're going back through looking through your new rules and you're unsure why something looks different, in certain cases Snort to Lua will put a comment there and explain what happened. So that's also really nice to have there. And then lastly, so that's pretty much it with Snort to Lua. However, there are a few caveats that I wanted to mention when using it. I think, in my opinion, one of the big ones is that Snort to Lua can't update rules to take advantage of all the new Snort 3 features. So, one of the ones Brandon talked about were HTTP param, the different optional selectors with buffers like HTTP URI query or path. And unfortunately, when Snort to Lua is going through rules, it doesn't have that context that, yeah, we might be looking for a particular string that is a parameter, but Snort to Lua doesn't know that's a parameter. So that's something to watch out for. And then another thing is that Snort to Lua doesn't perform any rule syntax validation. So what that means is basically if you pass a bad Snort 2 rule to Snort to Lua, chances are you're going to get an equally bad Snort 3 rule out. So definitely before you run your Snort 2 rules through Snort to Lua, make sure they work. Make sure there's no, make sure they're well formed and that Snort 2 doesn't complain about them when it uses them. And if you do that prior to running Snort to Lua, it shouldn't run into any issues. And then lastly, I just want to mention there are times where Snort to Lua might not, it might fail to convert a rule. I don't see this too often. I've seen it if you try and give it a rule option that doesn't exist in Snort 2 and you're trying to convert it to Snort 3. Sometimes it'll complain about that. And if it does, it'll drop a snort.rej file in the current directory. So that's definitely something to keep in mind. But yeah, I mean, that's pretty much it. It's a really powerful yet simple tool to use, and I highly recommend checking it out. So yeah, that's all I have, and I think Jeff is now going to talk about Snort 3's new tracing module.
Yep, thanks, John. Let me pull up my slides here. So this is the Snort 3 trace module. This is something new that we added in Snort 3. While we did have a way to dump buffers in Snort 2, it wasn't as easy or straightforward to do. With Snort's Snort 3's modular architecture, this is a little bit easier. So the trace module is configured in Lua. There's a bunch of different cool options you can do. This is for debugging local rules you might be writing, or maybe trying to evaluate maybe why a rule you've written is alerting or when it shouldn't, or isn't alerting when it should. So some of the common features we use, and there's a lot of features here, but I'm kind of condensing down to what is most useful for this slide deck. The first is rule evaluation tracing. That can give you a step-by-step per rule action, what's happening while the traffic's being evaluated. Buffer dumping is super useful. For example, Snort 3 will do encoding or decoding of certain traffic, and you'll want your content matches to match whatever normalization is happening in that buffer. Application ID tracing is super helpful. A lot of Snort 3 is geared towards application detection. So instead of port-based detection, you're able to run your rule, for instance, with alert HTTP or service tag HTTP. That means the rule is going to run on whatever traffic is detected as HTTP. The issue is, let's say you have some traffic and you're not sure which application the wizard's going to pick up on, or sometimes the application will fail to be fingerprinted, and that's totally a cause for a rule not to alert. So that's been very useful for us. Keep in mind, if you'd like to use the full range of trace module options, you want to use enable debug messages when you're compiling Snort. There are some trace module options that are always going to be available in production builds, but if you're going to use this in a wider capacity, let's say on a local machine, go ahead and use enable debug messages. And if you'd like to get more information on the command line, you can use help module, the help module flag with the trace module name. And you can substitute trace in that command for any Snort 3 module to get more configuration information. So let's do, here's some examples of the common options that I just described. So we'll also combine a lot of these together, and I'll show you that on the next slide. So FP search will show you the name, the human readable name of the buffer that the rule entered on. Buffer, and so you can see the Lua version on the right hand side. So this Lua is going to go either in your -- Lua command line flag, or it's going to go in your -C snort.lua config file. So rule vars, that's one that we use occasionally if you're using byte test or byte extract. These dumping the rule variables will let you know which values actually got extracted. So that can be helpful if you're doing comparing a byte that way. And then rule eval and wizard, which I talked about earlier. So here's an example of if you were to combine all of these together in one Lua file. You could maybe have like a tweaks file that, for debugging, this might be it. So we'll do an example. This is a very simple rule. We're doing alert HTTP, so this rule will run on all HTTP traffic that the wizard identifies. We're looking for rules that are client to server, and we're going to look in the URI for a specific exploit.html file being requested. So this is the standard out. You'll see if you're using that Lua file that I posted. So the first thing you'll see on the top, that's the wizard fingerprinting the service HTTP. So that's good. That means that our rule is qualified to run on this stream. The fast pattern has entered on the HTTP traffic, and we get a buffer dump. You can see on the third square there. And then at the very bottom, you can see where it says rule eval, starting tree eval. That means that the fast pattern is already entered, and now we're evaluating each rule option. So continuing on, this rule doesn't have any rule variables, but if it did, those would be printed here. And then at the very bottom, since this is a very simple rule, we see reached leaf, and then we see matched rule. So there's your rule tracing showing you that the rule has matched. And that's it for rule tracing. And if you have any questions, leave them in the Q&A.
Very good. Thank you, Jeff. And folks, if you have any questions after all of this that you'd like to enter, please go ahead and put them in the Q&A. I think we've got most of them answered, at least through the Q&A form. But if any of the panelists see something that perhaps they'd like to expand upon, feel free. And just a reminder, if you've got a question that perhaps is more specific to your environment and you'd rather not post it, then feel free to send it to me directly, and that's rallbach@cisco.com. So we'll pause a moment and just see if anything else comes up in the Q&A panel. I see Mr. Yao, who's been very active in the Q&A. Thank you, Mr. Yao, for that. Is this an explanation about after the update, we have the seam? I'm not sure exactly what that question is, but if someone wants to verbally answer that, or maybe ask what the oh, too late. It's already answered. No, let's see. It was question.
I think the question was around the number of rules in Snort 3. We said you can write fewer rules in Snort 3 to do, but then you need to Snort 2 for the same type of things. But right now they're still about the same, because yes, the rule sets that Talos is using, and you guys correct me if I'm wrong, are mostly, not all of them, but most of the rules have been used Snort to Lua to convert, so they're just one-to-ones. There's a little bit of difference, but right now, as time goes by and more rules are written native to Snort 3, then overall, radically, you should see a reduction in the overall rule count. So is that right, guys?
Yeah, that's absolutely correct. So currently we have we've translated the Snort 2 rule set to Snort 3, and we also have added on top of that native Snort 3 detection to perform actions that we want to do in Snort 3 specifically. And over time, we will be reducing the rule set, hopefully, quite a bit, because as you saw in our slides, a ton of rules that require, or a ton of detection that required multiple rules will only require one. So we should see on our products reduction in rules, which should be beneficial for customers, because there's less memory overhead required to run all those rules.
Excellent. And there's a suggestion that perhaps these are the same rule numbers after conversion. I wouldn't think so.
So the SIDs, for the most part, should be the same. The SIDs, the snort IDs for the rules, for the most part, should be the same. Like I said, we do have those native rules, which are on top of that. But on product, we have mappings between the signature IDs. So if you have a signature enabled in Snort 2 to detect a vulnerability, then when you move engines to Snort 3, that signature should still be enabled.
All right, wonderful. And there's a question about something that we've long been trying to address. When we do a rule update, are we going to have to restart the snort process? Pardon me. The answer should be no. Yes.
Right. So that in I can just speak to the secure firewall product. In 7.1, we've virtually eliminated snort restarts. There's, I think, one situation where if you change the file policy with the zip unzip option in it, I think, but there's like one thing that will actually restart snort. Everything else is a reload. The snort 3.
And a lot of work was put into that, so we're pleased to see that that question there. Anything else, attendees, that you'd like to ask? Well, not seeing anything. I want to thank everybody. We've had a very consistent attendance throughout the entire presentation. So thank you for taking your time. And I absolutely want to thank the Talos guys and their boss, Alan, by the way. Thanks for letting us borrow these guys for an hour or so. We're going to let them go back to saving the world. And this will be recorded. We'll get that posted. And if you would please answer the post-event poll. We want to know, what would you like us to see next in our next Snort 3andMe session? So thank you, everybody, and have yourselves a great day.
Thanks, everyone.